For section 5.5 on page 413, for our first question, we have to find the exact values of the trig functions. We're given a triangle. The first thing we need to do is find our hypotenuse, which I'm going to call radius since we're kind of thinking of the unit circle. And I do the Pythagorean theorem, so I'm going to have 1 squared plus 4 squared equals r squared. I'll have 1 plus 16 equals r squared. 17 equals r squared, so r will equal the square root of 17. I'm going to come over here on the side and write down what my sine of theta would be. Sine is going to be opposite over hypotenuse, which would be 1 over the square root of 17. And if I rationalize that, I get the square root of 17 over 17. The cosine value is going to be 4 over the square root of 17. And again, I have to rationalize that. It's going to be 4 square roots of 17 over 17. And then the last one, the tangent, is going to be opposite over adjacent for 1 over 4. Question 11, we have to find the cosine of 2 theta, so that we would be using the cosine 2u. And remember, this is like 3 different formulas, so this will be the formula I'm going to use. Writing my formula, I'm going to be using the cosine squared theta minus sine squared theta. I plug in my values. My cosine value is 4 square roots of 17 over 17. So we're going to have 4 square roots of 17 over 17 squared minus the sine value of the square root of 17 over 17 squared. Working that out, that gives me 16 times 17 over 289 minus squaring the square root of 17. I'm going to get 17, and squaring the 17 again, 289. The 16 times 17 in the numerator on the first one gives me 272 over 289, and subtracting the 17 over 289. And you can use a calculator to do these. You're going to get 255 over 289, and that happens to not be reduced. The final answer is 15 over 17. To do the sine of 2u, we're going to have to use the sine of 2u formula, which is going to be 2 sine u cosine u. So that's the first thing I'm going to do, is write that down. So now my formula is 2 sine, and I'll use theta instead of the u, times the cosine of theta. We go back up and we plug in our values. You can see that the sine value is square root of 17 over 17. I'm going to have 2 times the square root of 17 over 17. The cosine answer, plugging that one in, we're going to have 4 square roots of 17 over 17. Calculate this out, and feel free again to use your calculator on that. In the numerator, I'm going to have 2 times 4, which will be 8. Square root of 17 times square root of 17 will be 17. And the denominator, 17 times 17, happens to be 289. And instead of multiplying the 8 times the 17, I'm just going to cancel this out, because I know that will be 8 over 17 for my value. For the last one of this set, we have the tangent of 2u. So I come up here and I take my tangent formula. So we'll have to write that down. In the tangent formula, we have 2 tangent, and I'm going to use the theta again instead of the u. 2 tangent theta over 1 minus tangent squared theta. Plug in our values. Our tangent value was 1 over 4. This will give me 2 times 1 over 4 over 1 minus 1 over 4, the quantity squared. Working it out, 2 times 1/4 on the top is going to be 1/2 over 1. The bottom is going to be 1 minus 1/16, and 1 minus 1/16 is going to be 15/16. I'm going to multiply by the reciprocal, so 1/2 times 16 over 15, cancel that down. I end up with 8 over 15 for my answer for the tangent. If I look at these answers, make it small enough that we can see them. The tangent answer ended up being 8 over 15. The tangent is also the sine over cosine. So my sine answer was 8 over 17. My cosine was 15 over 17. The 17s would cancel. So the sine is 8 over 15, matches up with my tangent answer for question number 13.